all the programming languages and the AI/ML concepts. You said you are into coding, but were you familiar with the AI/ML concepts before this program?
So I've done a little bit, but not fully familiar with the AI ML concepts. I know like a little basics of Python. I learned about like pandas, skykit. Yeah, those.
Okay, that's great. So now let's begin with the presentation.
Okay.
Yeah,
Can you share my screen?
yeah, I can.
Okay. So, hello everyone. My presentation is about employee attrition prediction using machine learning. So before we get into the machine learning, let's talk about some current tech jigs. So currently, artificial intelligence is machine mimicking human intelligence. Machine learning, which we're doing today, is a machine learning from data patterns. Deep learning, which is an advanced form of machine learning that uses neural networks to analyze complex data. A large language model, which is trained on massive text data to understand and generate human language. Generative AI creates new content based on patterns, is like a LLM. And agentic AI, which is where a machine perceives their environments and makes decisions and can execute tasks. So now we'll talk about our problem statement. So the challenge here is that when an employee leaves a company, it costs 50 to 200% of their yearly salary due to recruiting, onboarding, and productivity. Current tools such as HR rule-based methods can miss small warning signs such as slow email replies, skip meetings, or negative tones in communications. Now let's talk about the solution. The solution is creating a machine learning model for attrition prediction. The benefits can be save money, spot attrition in employees early so managers can act before they leave. They can avoid work disruptions and can focus efforts on employees who are likely to stay. Now let's talk about the data. Finding the data set is one of the hardest challenges from implementing an AI model, as it can take days, even years, for data engineers to collect relevant and clean data sets. But in our case, there was a pre-made data set called HR Analytics Dataset by IBM. It has 1,470 rows with 35 features. The key features are age, gender, job role, monthly income, overtime, years at a company, and total working years. Now let's talk about the EDA. EDA is analysis done to the data set to gain basic knowledge about it. So number one is a correlation heat map. This correlation heat map shows how features are related to each other. Strongly related features can confuse the model, and we may want to remove them or combine them. For example, monthly income and job level are highly correlated, so we may want to remove one or combine them. Number two is an attrition bar chart. This shows that more employees that stayed, which is in the no column, is than the left, which is the left column, yes column. This data set is unbalanced and will need the SMOTE technique, synthetic minority oversampling, to even it out for training. Leaving the data unbalanced can cause the model to be biased towards people who stay. Number three, overtime versus attrition. Employees doing overtime have higher quit rates, which suggests that overtime may cause burnout or dissatisfaction, as this can be a strong predictor for attrition. Number four, marital status versus attrition. Single employees quit more often than married and divorced ones, as singles may not need a steady source of income compared to married and divorced, as they must have a steady source of income.
Hello, am I audible?
Yeah.
Okay, sorry. I think I got disconnected in between.
Okay.
Could you start from the EDA part from the start?
Yes, like this
Yeah.
is EDA. Okay.
Yeah, yeah.
Okay. So the number one, EDA is an analysis to be done to gain a basic knowledge for the data set. Number one is a correlation heat map, which shows how features are related to each other. Strongly related features can cause confusion in the model, and we may want to remove them or combine them. For example, monthly income and job level are highly correlated, so we may want to remove one of them or combine them. Number two is attrition, which is a bar chart. This bar chart shows that more employees that stayed, which is the no section, than they left, which is the yes section, as this data set is imbalanced and will need the synthetic minority oversampling technique to even it out for training. Leaving the data unbalanced can cause the model to be biased towards people who stay. Number three, overtime versus attrition, which is also a bar chart. Employees doing overtime have higher quit rates, which suggests that overtime may cause burnout or dissatisfaction. This is a strong predictor for attrition. Number four, marital status versus attrition. Single employees quit more often than married and divorced ones, as singles may not need a steady source of income compared to married and divorced, as they will need a steady source of income. Number five, job role versus attrition. High quit rates in research scientists and sales executives, as these roles may have higher stress or more job hopping opportunities. Department versus attrition. Sales and RD departments show the highest attrition. This could be due to workload, targets, or competitive job markets in those areas. Now, let's talk about data preprocessing. Based on the EDA of any dataset, we can identify what the preprocessing of the dataset would look like before the model is trained and tested. Handling outliers and nulls. In this dataset, there were very few outliers and no nulls. Feature engineering. Added two features: a satisfaction score, which combines job satisfaction, environment satisfaction, and work-life balance; remote stress score, which combined overtime and distance from office. Handling the class imbalance. For this imbalanced dataset, we applied the SMOTE technique, which helped balance out the dataset, and then train and test split, which split the data 80 to 20 instead of 70 to 30, which is typical, as this dataset is smaller than usual. Now let's move on to the model development. There are two types of models under supervised learning: classification and regression. In this case, classification model was used because we are only classifying the employees into a high-low risk attrition case using parameters like overtime, monthly income, etc. For this, we explored X decision tree, XGBoost, random forest, light GBM, cat boost, and a stack model. The top three were random forest, stack model, which contained random forest, XGBoost, light GBM, and cat boost, and then finally cat boost. Stack model had an accuracy of 0.8299, and then random forest had an accuracy of 0.8129. Cat boost with the same accuracy as random forest with 0.8129. Now let's finalize the model with the results. Based on the comparison, we found that stack model had the best results with about an 83% accuracy, but only a 55% recall and 47% precision, which means it misses half the actual attrition cases and can produce some false alarms. Now let's talk about deployment. We use Streamlit to make our application accessible to everyone. Now I'll show you a live demo of the application. Can you see this?
Yeah.
Okay. Yeah, so you can add the monthly income, age, overtime, total working years, distance from home, years at company, job satisfaction, environment satisfaction, work-life balance, and then it calculates the satisfaction score and the remote stress score. Currently, this is a low risk of attrition. Let's say if they do overtime and they're not that happy with their job, it will show a high risk of attrition.
Okay.
Uh, yeah. Now, future steps and conclusion. With this model, we can predict attrition to save costs and be more efficient than HR. For future plan, we can deploy a live HR dashboard for real-time usage. To make the higher accuracy, we can find a bigger and better data set with more balanced data. Thank you.
Okay. So that was